Looks like we're alive. Hello and welcome to another Zozin session. How about that? Something with my voice. Excuse me. Hello and welcome to another Zozin session. So let's quickly make a little bit of an announcement on our Discord server before we actually start slapping some code. And let's quickly do that. So this is going to be a red circle, live on Twitch. And what exactly are we doing today? Boys and girls, what exactly are we doing today? People already throwing money at me. I haven't started the stream. Thank you so much. Salaryman XZ for tier 1 subscription. Your first subscription, by the way. Thank you so much. Right, so today we continue developing our programming language called Porth. Right, so it's basically concatenative stack-based programming language that's sort of like inspired by Porth, but it's not really Porth. As a matter of fact, I'm pretty sure the adepts of Porth are gonna be mad at me for calling this language Porth, because in reality it's not Porth. The only thing that makes it related to Porth is being stack-based. Apart from that, it doesn't share the same philosophy. As far as I know, Porth is the whole philosophy. It's not just like a single language, right? It's like a cult, right? So it's like kind of dangerous to call anything stack-based Porth. But I find it easy to explain to people what my language is by comparing to Porth, especially when people never heard about concatenative languages or stack-based languages. So that's why I'm comparing it to Porth. So you can find the source code of this language in the description if you're watching it on YouTube, or you can find it here in the chat if you're watching it live. Hello everyone, by the way, who's watching it live, and welcome. Hello Iguduk, hello Butterbot TV, VDVR, Unneutral, Vilgontanel. I hope I pronounced your nicknames correctly. Hello everyone, really glad to see you all today. So on the previous stream, as far as I know, we started to rewrite the compiler in itself. That's right, so I think our compiler is mature enough to, to finally being rewritten in itself. And while rewriting the compiler in itself, we noticed a very interesting thing, right? We noticed that we want to have these long chains of if-else, right? Because they're easy to implement, and I don't know, I explained why I'm using them in the previous video, so I suggest to watch the previous video. I could have like used some sort of like a hash tables instead, but hash tables, I need to implement them in a language, and if-else chains are just easier to implement, which makes it easier to re-implement the language in itself. And our if-else construction is not really designed to have like long chains of if-else, and what you end up doing is having like a bunch of ends at the end, and in fact you have as many ends in here as you have else's. Right, so I recently started to redesign the if-else construction, right? So now it has the do keyword. So it used to be like this, right? So we used to have an if construction that looks like this, right? And you would put if after the condition. So the if would look at the thing on top of the stack and then make a decision whether to fall through into the body or jump into the end or jump after the else, right? Depending on how exactly you're using it. So, and I recently refactored it to actually look like this. Right. So the reason why I refactor it like that is because it will make it easier to introduce to what we are about to introduce, right? And on top of that, it makes it a little bit more consistent because we have a while construction, like a while loop construction that looks like this. Right. So, and as you can see, they kind of look similar now, and it makes it super easy to refactor if block into a while block if you want to do that. Right, so that's why I decided to use do instead of then. And the way I want to get rid of these chains of ends is to introduce a keyword else if. It's basically the same solution as in Python, right? So I think Python did the same solution. So basically elif sort of continues the the chain of else ifs, and that way we'll be able to get rid of all of these ends. Right, so but before I gonna do that, I think I want to do something different, right? Because while I was refactoring conditions from looking like this, right, from looking like this to looking like this, I encountered a little bit of a problem because it was kind of difficult to refactor things, right? So the way our code is organized, it made it a little bit difficult to refactor all of that. And so all of these keywords are in fact our operations in our intermediate representation. And for instance, do is an operation that contains an address where it has to jump when the condition on the top of the stack is false. So it knows the location of end. Right, and in case of else, right, it knows the location of else, and the else itself knows the location of end in case you want to fall through and just jump over the end. So all of these keywords are effectively instructions of the intermediate representation of the language that we simulate or generate the native code from. Right, and while I was refactoring all of that, I find it difficult to actually keep track what these instructions point to, right? So for example, did I put the address of do correctly to jump to when it's true or false and stuff like that? So, and I had no way to even visualize the control flow, right, as I was refactoring the constructions. And I think it was like super important for me because some of the bugs that I encountered, that I introduced while refactoring things, I could have avoided if I had some sort of a visualization of control flow and what the operations point to. So, and the first thing I want to do today is to introduce a little bit of a feature into our compiler. I want to add a small flag that on top of compiling the program also generates a graph of control flow. Basically, it generates a dot file that can be fed into GraphViz, right? GraphViz. Let's take a look at the GraphViz. Do you guys know what is a GraphViz? GraphViz is actually a pretty cool thing. So essentially, you can describe graphs in a very simple language, right? Basically, you can just describe nodes, describe edges, and just have like a small file, textual file, and then you can render it into something like this. Right, so what I want to do, I want to actually take all of the relationships between the operations and how they flow, generate a graph out of that, and render it into a picture so I can analyze if I didn't make any mistakes while refactoring the control flow instructions. You see what I'm talking about? So I think it's going to be very useful. It will make it super easy to like notice if I introduced any bugs and stuff like that. Does it sound good? Does it sound interesting? This is something that I want you to have. As far as I know, I think compilers like GCC or Clang have some ways to generate like AST graphs or something. GraphViz is actually quite often used by the compiler developers to debug things because it can quite easily take a graph data structure or a trigger data structure and quickly visualize it. So it's super convenient. So yeah, and the first thing we're going to do today, we're going to introduce a small flag that dumps the control flow graph of your program for further analysis. And I think it's going to be very useful. So, yesu, kawaii freaking desu. Does anyone have any questions about that? So, okay, that's pretty pogue. Thank you. I also think it's pretty pogue. Alrighty. Okay, let's go ahead and do that. Less ago. So I'm going to remove this entire thing, and how we're going to call this entire branch, right, where we're going to implement the feature. I think I'm going to call it control flow, right? Control flow. There we go. So, and I think I'm going to actually just go ahead and introduce a new flag to the compilation subcommand, right? So we already have a bunch of flags in here. Let's introduce another one, right? It's going to be something like, I don't know, CF, right? Dump control flow graph of the program in a dot format, right? In a dot format or something like that. So we're gonna have this kind of flag. I didn't get voice on Discord after subscribing, so you have to connect your Twitch account with the Discord, and the server will give you the permission automatically. You probably didn't connect your Twitch account, because otherwise they are linked. Okay, so that's very strange. That's kind of sus, I would say. I'm gonna actually go to the integrations and just quickly see if I can sync everything. So just a second, it's taking some time. Sometimes it requires like forcing the synchronization between Discord and Twitch, and for some reason it takes some time to even sync, so maybe there is some problem. Okay, I'm gonna take a look at that after the stream. Okay, so thank you for bringing my attention to that. All right, so let's continue. So yesu. Where do we handle the flags? Okay, so here's where we handle the flags. So if we encounter -cf, we need to set up the following thing. So let's actually create a variable called control flow. Right, so this is going to be false, and if we encountered control flow, we're going to just set control flow to true. There we go, but by default control flow is going to be false. And essentially, after we parsed the program, right, we want to dump the graph, the control flow graph. Hello, Coppercasted, hello. So if control flow is enabled, we want to maybe generate control flow graph as .file, or I don't know how to call this function, right? So, and we're gonna give it a program, and I don't know, we have to give it some sort of a name, right? So we already have such thing as a base name, right? So maybe we can use something like a base path, right? So this is gonna be base path dot. There we go. Generate control flow graph as .file. So, and maybe we want to actually log that we're generating a file, but maybe we can do that inside of that function, right? So let's actually put it somewhere here. Parse program from files, so let's actually do it like this. Define program is going to be the program, right? And this one is going to be .path, which is going to be a string, right? All right, so this one is going to be not implemented. Generate control flow flag. Alright, so this is going to be Porth Pi, and if I try to compile something, so let's actually write a very simple program. Maybe we already have a simple program, something like hello world, right? So here's a hello world. It's a very simple program that just calls one single macro. Matthews F777, thank you so much for 34 months. Thank you so much for 34 months of tier 1 subscription, and welcome to our epic Porth club. I'm gonna take a look at the situation with the Discord after the stream. Thank you for bringing my attention to that. So let me see. Right. I really apologize for the Discord. I don't know, sometimes it just doesn't sync, so for whatever reason. Alright, so let's try to compile a very simple program, something like example hello world Porth. Alright, so, and as you can see, it compiles everything, and if I enable cf, right, as you can see, it fails in this function because this function is not implemented. So the first thing we probably want to do, we want to open a file, .path, and we want to open it for writing, right? So do I want to open it as binary? Let's open it as binary, whatever. Though, yeah, I think it makes sense to open it as a text file. So with open as f, and we're gonna start generating things. So as far as I know, how do you generate a graph with a graph width? Not width, but width. So graph dot Right, so there are different kind of graphs that you can generate. So there's just graph, and you can give it any name, right? So here's like some sort of a name, and then you can say that it has foo that is connected to bar, and I don't remember, I think the edge is represented by a double dash, right? So you have a foo and it connects with bar, and you can put a semicolon, if I remember correctly. So, and then, oh, that's pretty cool. So Emacs automatically recognized that I'm inside of a dot file, and it suggests the command line to actually render that. This is actually super convenient. Twitch 000 Alan subscribed with Twitch Prime. Thank you so much for a subscription. Welcome to the Epic Porth Club. So Emacs is very smart. So I run that thing and I can take a look at this entire stuff. So there we go. We have two nodes that are connected together, right? So if you want to have like more nodes, you can do something like bar buzz, right? So if I do something like this, if I re-render this entire stuff, there we go. So I have 3 nodes and stuff like that. So if you want to have another node that coming from, for instance, foo, right? So you can do it like that. You could just add a bunch, like another edge, and it will be rendered correctly, right? So now we'll have another node coming from foo. As you can see, now we have like a small tree, right? So, and what you have to generate if you want to dump some sort of like a tree structure or graph structure, you just have to dump a list of edges, right? But this is just a regular graph. So there's also a thing called dgraph, which is a direct graph. And direct graph, like each edge of a direct graph, is it called direct or directed? I don't remember. But each edge of the dgraph, it has a direction. So you say that the edge goes from foo to bar, but not from bar to foo, right? And you actually do that with the arrows, like with the small arrows. And if you try to recompile this entire thing, like re-render it, it will look like this. So now they have these small arrows. Arrows, not errors. Directed. Okay, so it's called directed. Okay, thank you. Cool. So, and as far as I know, you can also stylize your nodes. For instance, you can just mention a particular node by itself, and then you can say something like style. And one of the style I remember is a record. Maybe it's not a style, I think it's a shape. Right, I think it's a shape, and you can say it's a record, right? And if I re-render this entire thing and I open this stuff up, as you can see, foo will be square, but the rest of these things are going to be you know, circular. So we can customize the style of different things, and as a matter of fact, you can have a pretty complicated styles, as you can see. So you can group nodes, you can have like really weird shapes and whatnot, and all of that is documented. So just check out the official website of GraphWiz. It's actually a very useful tool if you need to dump some graph information or some tree information. So I'm going to put this entire thing, the link to the GraphWiz website in the description. So here's the GraphWiz, and for people who's watching live, I'm going to put this in the description. So yes. I'm writing a compiler for a class and I wrote my own method that prints an IST to the terminal. I wish I had known about the .graph data. Okay, so yeah, it's actually very useful. As far as I know, like a lot of compilers have like very not well-known flags that can actually generate information about like different internal structures. As far as I know, GCC, I think there is some sort of like small unknown flag in GCC that allows you to dump AST as a .dot file or something like that, but don't quote me on that, I don't remember. But I think there are things like that in big debuggers that are used for debugging, in big compilers that are used for debugging the compilers, right? So, all right. So we're going to be using a dgraph, and we're going to just output the operations, right? We're going to just output the operations and see how they go. So let's go. So first thing we need to print. We're going to write do graph, and what's going to be the name? I don't know, we can do something like program. Let's actually call it a program, right? So this is going to be the program, and then in here we're going to close this entire stuff. There we go. So I'm going to iterate all of the operations within the program, right? So this is going to be IP in, oh, just a second, in a range len program, right? Something like this. So program IP, and honestly, majority of the things, they don't really need to be specially treated. So what I want to do is probably, yeah, I'm gonna start handling things. So the first thing we're gonna have, Flinzy, thank you so much for Twitch Prime subscription. Thank you, and welcome to our epic Graph Club. Graph Club. I need to start actually, taking my pronunciation a little bit more serious, right? So I always confuse the sounds like and because I'm Russian, and in Russian language we don't have that many goddamn vowels. Why English has so many vowels? I don't understand. Anyway, here we're gonna have OP type. So the kind of types that we're gonna handle is probably OP type intrinsic, right? Because majority of the things we have in here are intrinsics. And when we encounter the intrinsic, right, so what I want to do, I want to print right, then I'm gonna indent a little bit, 1, 2, 3, 4, and then we need to probably use like a general name for the nodes, right? So each individual operation has to have a unique name of the node, right? So I think the easiest way to have a unique name is just to use the IP as the node name. So we want to have something like node underscore IP. So to be fair, we're going to have a lot of formatting for generating this kind of stuff, and I think I want to start using f-strings for this specific thing, right? So I'm going to actually do it like this. So this is going to be node IP, and since it's in intrinsic doesn't really affect the control flow, right? We're gonna say that the node IP goes into node IP +1, right? Intrinsic don't usually alter the control flow. The constructions like if, else, and while they do alter the control flow, and for them we're gonna actually generate things slightly differently. So here's the intrinsic, and if we encounter something else, we're gonna just do assert false unknown, maybe unimplemented operation, right? Unimplemented operation, and what we're gonna do now, we're gonna just run the program and see, rather observe how it's gonna fail. Okay, so we have unimplemented operation, so maybe I'm gonna actually print the unimplemented operation. So this one is gonna be OP. And what did we get? I'm gonna actually print the type. So, and okay, so this is a push string. Cool. Let me see. If we encounter OP type push str, push str is almost like intrinsic. It doesn't really affect the control flow, so we're gonna do it like that. What else do we have in here? So this one has to be equals. So then we have push int. I think push int is pretty much the same, right? And there we go. So we generated something, though it doesn't say that we're generating dot file. So let me quickly do that. I'm gonna print info generating got seed, right? So this is gonna be dot path dot, and let's see. There we go, generating dot. Maybe I don't even have to put dots in here. So now we know that we have some dot files in here. All right, so here's what we generated. I can already see that we forgot to put semicolons at the end of this entire stuff, right? I think you have to end everything with the semicolons. Right, so maybe I'm gonna do auto revert mode, right, and then I'm gonna go to the compilation, and as you can see, it automatically updates everything. Isn't that convenient? I think it's pretty convenient. So I can also do something like this, and I can get rid of the underscores, and I can recompile everything, and as you can see, it automatically reverts everything. It's almost like it's a proper text editor. It's almost like it's a modern text editor. So, okay. So another thing I want the compiler to do on top of generating the dot file, I would like it to actually render that dot file. I think that would be convenient, if you know what I'm talking about. So the question is how you can do that. I think you can call dot tpng, but here is a really weird quirk about dot utility that renders the dot files. It's a really weird quirk. I'm gonna show you. So if you try to do it like that, just a second, dot tpng examples hello world dot, it prints garbage right into your terminal. So by default, this thing dumps the content of a PNG file into the standard output. For whatever freaking reason, completely breaking your terminal. So basically you're supposed to redirect it yourself, right? World.png, and then you can open this entire thing, and there you go, here are the instructions, right? So I have no idea why this is the default behavior, because as far as I know, dot is capable of outputting that to a file, right? So I think it's, I don't quite remember the flag, so let me take a look. Yeah, automatically generate output file names based on the input file name and the T format. Like, I have no idea why this is not a default. Like, convenience is not the default option in open source world, apparently. So yeah, this is what it is. Anyways, so I suppose what you have to do if you want this thing to be like automatically, right? So you have to do it like that. And even then, they took a very lazy approach to generating a file name. So they just append .png at the end of the name without removing dot, which looks kind of ugly. And okay, so maybe we can deal with that. It's just like, I mean, it's actually not important. All of these things are very minor, but they're kind of annoying, don't you think? Like these small things, like they're kind of annoying. But anyway, whatever. It is what it is. It is life. Nobody asks me. So yeah, let's actually, after we generated this entire thing, I think I'm gonna call cmd call echoed and just generate the final PNG file. Or maybe it would be better to actually generate SVG file, because it's a vector file, and you can scale it indefinitely. So let's actually generate SVG instead. I think that will be more convenient. So cmd call echoed. So what we're gonna call in here, we're gonna call a dot t svg -o, and the input is going to be dot path, and I think that should be enough, right? I think that should be enough. So now if I try to run this entire thing, as you can see, it generated dot, then it rendered dot file, and now we can take a look at what we've got. So if we take a look at the examples, so here is a hello world, here is SVG, and I really want to open SVG in the Chromium, right? Chromium, the browsers usually better show the you know, SVG files. So as you can see, I can scale it indefinitely, and I can even select the text within the SVG. So I think SVG is a little bit better format for this kind of stuff rather than PNG, in my opinion, right? So we're going to work with SVG, and on top of that, as I change something, I can just refresh the page, and it will also refresh the image itself. So I think it's a pretty good idea. Anyway, so you can notice a very interesting thing. We don't really know what kind of intrinsics we have in here, right? We don't really know. And this is because these kind of nodes do not reflect what's actually displayed. So as far as I know, you can specify the style for the node, right? So we can say something like node IP. And if I remember correctly, there is a label, right? There is a label property for the node, and you can say something like hello, right? And for instance, if every time you encounter intrinsic, you will see hello. Or rather, let's actually put intrinsic in here. Intrinsic, right? There we go. And let's see what's gonna happen. Okay, so if I refresh this entire thing, as you can see, each intrinsic was replaced with the word intrinsic, which makes it rather convenient, right? But it would be better if we knew exactly what kind of intrinsic we have in there. And as far as I know, we can. So there is a dictionary here, intrinsic name, right, which basically allows us to map the intrinsic ID to its textual name. So let's quickly do that. I think I'm going to do the following thing. So OP operand, right, so this is going to be something like this, and intrinsic name, and I'm going to just map this entire thing like that, and I'm going to rerun the entire stuff, and as you can see, something went wrong because I don't have a single name, I have several names. Alright, so, and as you can see here, we have syscall3 and drop. So the reason why we have a syscall3 and not puts is because puts is not an intrinsic, or like, yeah, it's not an intrinsic, it's a macro. So, and if you take a look at how this macro is defined, it expands to std out fputs, and fputs yet another macro that eventually expands into write, and write is yet another macro that eventually expands to the syscall3, which is intrinsic. So as you can see, it's like an onion of macros, like onio, right? The entire language is basically an onio of macros. That's what it is. So yeah. Yeah, it's pretty cool. So for the rest of the things, I think like node 0, node 1 are basically strings and integers. So for those things, I think we can also have something. So for numbers, we can just, you know, show the numbers as their label. So I think that will be actually convenient, right? So node IP label. Oh, it feels like this thing just worked without any semicolons. I'm going to put semicolons anyway. So an label is going to be essentially OP operand, right? An operand is just like a number, right? So and that should be fine. That should be fine. There we go. So here we have 1, 1, and 1 means that we push 1 on top of the stack. All right, so that's pretty cool. So, and for the strings, I would like to probably print the strings themselves, but some strings are very, very big, which may result in graph being completely unreadable, so maybe we'll have to truncate them to some degree. So it feels appropriate to have boxes around nodes expanded from macros, but that's probably better left for the future. The problem with this kind of stuff is at this point, when we received the program, we lost all of the information about macros at this point. Right, so yeah. As far as I know, as far as I can remember, all of the macro expansion happening at the parsing stage, and after the program is fully parsed, it's all of the macros completely expanded, so there's no information left about macros. But we do have some information still in the tokens. Okay, here's the thing. Here's what kind of information we have. So if you take a look at the program, it's a list of operation. Operation is basically a single instruction in the intermediate representation of the language, right? And each operation has a token associated with it. So basically, from which token that operation was compiled, right? And here's the interesting thing about the tokens. Tokens refer to other tokens from which they were expanded. So basically, a single token is a part of a tree of the macro expansion. So, and this information is needed when we need to print the macro expansion stack trace, right? So if the operation fails, we print its location, then we go to the parent location of the token, then to the parent, then to the parent, and then we show the full stack. We can use that stack to visually show from which macros what was expanded at some point. right? But that's kind of outside of the scope of what we're doing right now. Right now, I just want to show the control flow of the program so I can easily refactor the control flow instructions. What you're suggesting is going to be good for debugging macro expansion, which could be a problem in the future. And if in the future we'll need to debug macro expansion, I will probably use this information to add to the final visualization. So this is actually a good point. Thank you so much. Right. So yeah, that's basically how what kind of information we have about the macros, right? So if you have a token, you know from which other token it was expanded during the macro expansion. So yeah. So it's basically like a tree of the expansion. Generate control flow graph. So strings, yes. This one is going to be node IP, and we're going to have a label. So for the string, I want to have what? I can put an operand, but I'm not sure if it's going to work properly, right? So I'm going to do it like that, but you never know. And as you can see, we already have some sort of an error, and yeah, so I didn't make it an F string, a proper F string, what I mean. Yeah, there we go. So this is because the string, it has a new line in it, right? If you take a look at the hello world, we have a new line, and it was actually put in here, you know, verbatim. I think this is how we pronounce it, right? So it was just, yeah, put in here verbatim. So we need to probably escape it somehow, and also I forget a new line somewhere here, so let me quickly see where I forgot new lines. So I forgot new lines in here. Okay, so let me see. Graph viz escape strings or something. I don't remember. Escape label escape. Okay, how can I use in the label in a graph viz? Okay. Backslash to escape, so you can put this kind of stuff. I vaguely remember some time ago that you can use HTML. Can I use HTML escaping in a label? Because I vaguely remember that you can do HTML things in there. Yeah. Put the text quotation. So, okay, so they're suggesting to put just a quotation. Okay, so we can try to do that. Why not? So the string, where is the string? And I'm gonna just put it like that. But unfortunately, we still have to escape the new line. You see? Right. So if I just, yeah. So it still contains this new line, but this time it's not that bad. Right. So here we have a hello world. Maybe it's fine. Yeah, maybe it's fine. It's fine. So we have a hello world, but on top of that, I also want to have like, you know, string. So what if I do double escaping of this stuff? So it feels like it's not really working super well. Oh yeah, so I have to escape the escaping and then escape. Oh my god. Okay, so this is the classic, am I right? And if I take a look at this entire stuff, there we go. So and in Porth in here, so I also forgot a new line in here, of course. I keep forgetting this stuff. So we are escaping unescapable, and there we go. We also have a new line in here, which looks absolutely horrible. Okay, so graph with label escape new line. Can I new line in a node label in dot? Can I escape the new line? Well, yeah, alright. So Python escape string. Right, so Python how to escape special characters. We already did that at some point, didn't we? Right, so so you can translate the things, you can do regular expressions, and stuff like that. I think we have unescaping, right? So we have unescape. Yeah, we unescaping this the thing. So Unicode escape. We are decoding this entire stuff as Unicode escape. Wrapper. Oh, okay. So yeah, people say in the chat something about wrapper, and I completely forgot about this thing. IPython, come on. If I have something like hello world new and I just print this entire thing, right? And then if I do wrapper, okay, so this is actually very useful. Thank you so much. I really appreciate it. Yes, I'm not the Python developer, so I don't know stuff about Python, so thank you so much. So it's a representation, apparently. So a wrapper, and because of that, maybe we don't even have to like put this madness in here, right? We don't really have to do that anymore. And if I take a look in here, it still shows me the new line. God damn it. Really? So even though... Okay. So I need a double escaping of this entire thing, I feel like. I need a double escaping. A wrapper. Okay, so is wrapper going to give me what I think it was going to give me? Yeah, probably that's what we need. I think we need a wrapper. Double wrapper. So now it has a problem in here. Okay, so that's very interesting. So why does it have like a double shit in here? This is because... Oh, yeah, I see. So that means if you want to have a wrapper, you don't need the outer layer of quotes because it's going to be generated by Python itself. Okay, so I think we hacked the system. Look at that. We hacked the system finally. And if we take a... Perfect. So it's a double wrapper without manual double quotes because they provided by Python. And if something changes within how a wrapper works in Python, this entire code is going to break, which is absolutely in the spirit of any Python application. I really like that. So... I love Python. It's my favorite programming language of all time. Oh my god. Anyways, so cool. And we have a mysterious node 5. Right. We have some sort of a mysterious node 5. So what is a node 5? It's a very interesting question. So you see, every time we encounter a thing that does not affect the control flow, we just do IP+1. So if the last operation does not affect control flow, it's gonna point to the next operation that doesn't exist. Right, and this is what node 5 is, so it's basically out of bound node, and that's why it doesn't have any name, even though we sort of handled all of the nodes in here, so it's kind of strange. So one of the things we can do is maybe give it some sort of a name, right? It's a ghost node, yeah, exactly. So let's do it like this: 1, 2, 3, 4 node, and that node is the length of the program, right? So it's the last node, and it's going to have the label. And let's just call it halt, right? Because after that node, once you reach the halt, the execution halts, right? There's nothing much to say in here. And it doesn't even properly compile because why? Because I didn't mark this shite as the F string. All right, so, and what else do we have in here? I see. Yatka subscribed
Porth
with...
to the moon, raketa.
Thank you so much for 7 months of Twitch Prime subscription. Thank you, and welcome to our Epic Porth Club. So, Yesu, kawaii freaking desu. So, let's take a look, and as you can see, we have a halt. So, here's the program. So, the first thing we do in here, we push a string literal, then 1, then we call syscall, then we drop, and then we halt. So, we can craft a more, like, you know, readable example, something like full Porth. Something like 34, 35 plus and print, right? And if I try to do something like full Porth, Right, and oh my god. Oh my god. I guess we have to repeat the same trick as with the string literals. I have no choice, but that's basically what we have to do. Okay, so plus is an intrinsic, right? So essentially what we have to do a wrapper, right? So let's take a look at the wrapper and see if it's going to help us. Okay, so now we have a problem with double quote. Is there any way for the wrapper to actually use, you know, specific quotes or something like that? Return the canonical string presentation for new object types, most built-in, blah, blah, blah. Okay. It is what it is, and it isn't what... Yeah, so this thing doesn't really like that. It doesn't really like that. So we have to do maybe double. Right, maybe we have to do double. So this is a wrapper, right? So is it gonna work? It is working. And so what I probably want to open in here is foo.svg. There we go. So we have this, you know, quotes around the intrinsics, but maybe that's fine. You know what I'm talking about? Maybe that's fine, because all of that is for debugging purposes anyway, right? So it's just like for us, and we do understand what the fuck is going on, so maybe that's fine. Alright, yeah. So now, what do we have? So now we need to add control flow, right? So do we have any programs with the control flow? I think the program with the control flow we have is the name program, right? So this thing asks your name, and you provide your name, and then it says hello that name. So let's actually take a look at how this program works. So do I have a terminal opened in Porth? Yes, I do. So Porth pi, and I'm gonna do examples name.porth. Right, so it asks my name, here's my name, and it says hello that name. So obviously we do have conditions in here, and I just want to see the control flow of these conditions. Okay, so let's go. So this is going to be name, and it should fail because, as you can see, an implemented operation OP type if, right? OP type if. Elif OP type equal OP type if. So what's interesting about if is that right now it doesn't do anything. It just falls through, right? It simply falls through. So because right now our control flow is basically handled by do. Right, so you fall through the if, you execute the condition, and then do decides whether to fall through into the body or jump after the end based on that condition. If is here more for the type checker to know at which point to get the snapshot of the stack and compare it with the snapshot of the stack after the body. So it's more of it for the type checking and also for the visual thing. So in case of if, we just basically fall through. So this is going to be that 1, 2, 3, 4 node IP, and here we're going to have a label. So in the label we know for sure that it's going to be if. So maybe for the control flow instructions, for anything that is related to control flow, we want to have a different style, right? So maybe we're going to have like a shape record, right? So this is going to be shape record. And after that, we're going to just fall through. 1, 2, 3, 4, node IP, node IP plus 1. There we go. Cool. So now, if I recompile this entire thing, as you can see, now it complains about unknown do. And do is interesting. Do can either fall through, right, just go to IP plus 1, or jump to another place. And we have to visualize both of the situations. So basically there will be two arrows from do. one for the true situation and one for the false situation. So, and maybe we want to style them differently to know exactly which one where it goes. Especially when the graph will become complex, it will be not obvious which one is true and which one is false, which path, I mean. So OP type do. Right. Emacs, why did you actually move in here? I don't understand. Alrighty, so this one is do, and we either fall through or we jump to a different place. By the way, I forgot to actually put on Discord right here. So, and where do we jump? Well, if the operation is do, it contains the address where to jump to in its operand. So we basically jump into the operand. So, and that should be fine. Okay, so let's recompile the other thing, and now we have AND. So as far as I know, AND is very similar, right? So it's actually almost like do, but it always jumps to the operand. You see, do can jump either to IP+1 or to the operand, depending on the circumstances, but AND always jump into the operand. So, and this is basically because we use AND for both if and while. So in case of if, AND always jumps to the next instruction, to here. In case of a while, AND always jumps back to the while. You see, it's unconditional jump. Do is a conditional jump, AND is unconditional jump. That's basically what it is. So yeah. Essentially, I just gave more human-readable names to conditional and unconditional jumps, and this thing is more of a label for unconditional jump of AND. So this is a label, unconditional jump, conditional jump. So this is actually pretty cool. I really like that. Now we need to do something like this. If OP type is going to be equal to OP type AND, and in here we're also going to have the square thingy, but we always jump to the next stuff. Alright, so we implemented everything, and let's take a look at the control flow of the name program. Isn't that exciting? I think it's kind of exciting. So now we'll see the actual interesting control flow that is not just a straight line. Let me take a look. So here it is. Drum roll. So here is the control flow of what is your name, right? This is pretty cool. So here's the if, then we check a condition. So if it's a false, we say the error and then go to the end, I suppose. Though here, as you can see, we actually go into the exit syscall, so around here the execution will stop. In case of a true, we're gonna go in here and we're gonna continue doing this thing. So here, what we do is essentially, yeah, so we have additional condition here for whatever reason, and I really like that. So yeah, so here is the conditional thingy. I think we don't have an else in here. I think we don't have an else. So we need to find something that has else. As far as I know, in examples we have fizzbuzz. Oh yeah, fizzbuzz is interesting. So as you can see, there's a lot of decision making in here, and also there is a while. So we don't have support for whiles. Let's actually try to render while and make it work. So fizzbuzz. Alright, so what we have in here is while. While is basically like if, it's more like for decoration, it's like a cosmetic keyword. Cosmetic keyword, yes, that's literally what while is, it's a cosmetic keyword. But it acts like a label for AND to jump to. Can we somehow print true or false on top of the arrows? I think we can. Arrow labels. Right, arrow labels. Oh shit, why did I Google that? I'm stupid. Graph viz arrow label. There we go. So how to add edges labels in graph viz? Oh, you literally do it like that. Okay. So in case of a do, so I think this is true, right? and this is false, right? So this is gonna be false. Yeah, so, and now, if I compile name, and let's take a look at the name. So where is the name? Here is the name. There we go. So here is the true. Yeah, this is the true. So because we specifically check for the error. If there was an error, we go to the true. Otherwise, we go to the false and skipping all of this stuff. So I think maybe for false, we also want to have like a completely different style, right? Graph with arrow style, maybe like a dashed arrow, dashed line. So there's different arrow shapes, but I want a different line style. I wonder where we can find that. Arrow shapes, line style. Albert line style. Holy shit. It's a perfect name for like some sort of a vector graphics software. Albert line style. So dumb, I love it. Okay, so arrowhead. This information is useless, by the way. Graph with dashed line. Yes, that's what I want. Could you know the shapes? Style attribute. So there's a dashed, style. Okay, so you just do style dashed. Finally, thank you so much. So in case of a false, maybe we're gonna do style dashed. Right. So, and if I recompile this entire stuff and I take a look at the name, there we go. So as you can see, true is a solid one and false is a dashed, and we have a specifically named false. Looks good. It looks good to me, actually. It's pretty nice. And I really like that it just curves here and just tries to make it look nice and stuff like that. Makes it easy to, you know, to look into this entire stuff. It's actually a pretty good control flow, not gonna lie. I like that. Okay, so we need to do fizzbuzz. I think fizzbuzz is gonna finish the rest of the stuff. So else, I think else is basically like end, right? It's unconditional jump. So let's go ahead and do that. So this is unconditional jump, this is else, and this is else. All right. Okay, fizzbuzz is done. Let's take a look at this stuff. Fizzbuzz SVG. So this is gonna be Chromium. And alrighty, so here's the... You can already see that this is a loop, by the way. You can already see this is a loop and it goes back to the while. So we duplicate this stuff, then... Oh, and then we even have a halt in here, somewhere here. Oh shit, this looks kind of cool because of like a lot of decision making, right? Because we have like if else, and it's just like, you know, branches a lot. So that's pretty cool. I think that's pretty cool. And here is the trail of ends. Look at that. This is the trail of ends, and just everything goes into the end. If you go into one end, you basically go to the last end, no matter which one you go. So you can clearly see that it would be nice to actually collapse this end into a single end. So that would be nice. But yeah. And then that last end, right, jumps back to the beginning. It jumps back to the while, and this is basically the loop that we have. So that's pretty cool. Let's take a look at something more complicated, I suppose. What about, for instance, Game of Life? Right, so I think Game of Life is one of the complex programs that I have. So I already showcased that thing several times. This is how it looks like. It's written in Porth. It's like a semi-interactive program, as you can see, right? It's just like re-renders everything. There's a lot of logic in here. So if we try to visualize the Game of Life, how it's gonna look like? Oh man, that actually takes graph with some time to even render. Holy fucking shit. So Okay, that's very interesting. All right. So Graphy is apparently okay. So it's done. I was like actually afraid. So Graphy is having a little bit of a hard time visualizing this entire thing. So let's see if the browser will be able to even show it. Okay, so 1.2 megabyte. So this is a 1.2 megabyte SVG XML file. It's an XML file. So let's take a look at this entire stuff. Oh boy. All right. So we start with a straight line, right? And then we go down. So we have a lot of stuff. So maybe I'm going to actually speed up the process. Okay, so we have a... Oh my god. Holy fucking shit. That's a complex program, not gonna lie. There's a lot of things in here. Okay, so... Yep. I think it doesn't really make sense to analyze such a big programs, right? So you probably want to like reduce the size of the example you're working with to something more manageable to debug the jumps and stuff like that. But yeah, it's capable of rendering this kind of stuff. That's pretty cool. So, yesu, kawaii freaking desu, how about that? So, yeah. What about the compiler itself? So we have a partial reimplementation of the compiler in itself, right? So porth.porth. I think the compiler itself is not as complex as the game of life, but we can try. Well, there is a lot of strings in here. Here's the thing. There is a lot of strings in here, and they will make the graph way too dank, in my opinion, right? I think it will make it way too dank. Let's go ahead and just try to do this thing. So this is gonna be porth.porth, right? Porth.porth. And we have something not implemented. Oh yeah, we have not implemented C strings. Did I mention that? I think right before the stream, I introduced C string literals, yeah. So if we take a look at this entire stuff, so now you can define literals that look like this. You just put an S, I mean not SC, after the string literal, and essentially it makes two changes. First of all, it doesn't push its size on the stack. So the regular string literal will first push its size onto the stack and then the pointer to the beginning of the string. So this thing will only push a pointer to the beginning of the string. The second thing it does, it adds implicitly a null terminator at the end of the string. That way you have a classical C string that you can pass to C functions, right? So a lot of syscalls, for example, open file syscall expects a null terminated string, and because of that you want to have a convenient way to define null terminated string. Luckily it was actually super easy to change, like it's almost like a parser level of change. Not really like I had to also change the intermediate representation, but it's actually a very simple change that I wanted to actually add, and it makes it pretty convenient. It makes it pretty convenient. So if you want a C string in its size, you still have to manually do /0. Yes, and it's not that difficult to do, I think. So to be fair, it's quite rare, I think, when you want both null terminated string and its size, right? So we either want one or another, right? Okay. We'll see. All of the decisions can be changed at any point. This language is still in experimentation phase, so. But for now, I think this is fine. Anyway, so we don't have a dumping for the C strings, so let's go ahead and add this thing in here. So it should be relatively straightforward. It's almost like a string, but it's a C string, and it stores its value also in operand, right? Okay. My PC explodes. Yes, exactly. My PC is too weak for graphics. Okay, so what we need to do now, we need to open the porth.svg. Okay, so this is going to be a Chromium, and oh my. Okay, so it starts somewhere. Okay, so it's actually pretty big. So here are the strings. So we have a lot of strings in here actually. So here are all of the strings. So at which point is gonna go, oh my god, here's a huge loop. Look at that. Oh yeah, it just goes like that. Yeah, so this is basically the loop in here. I think it's not particularly productive to actually analyze such a huge... Holy fucking shit. Can I actually, like, reduce the size of this entire stuff just to see how huge of the graph this is? Holy fuck. Holy fuck, mate. I can't see shit in this. Holy fucking shit. Can you even see that? Yeah, I think you should be able to see that, yeah. That's a complex graph. Yep. So that's the compiler itself. Pretty cool, isn't it? Okay, so let's actually commit that. So now we have a feature. So this is the feature for the compiler. So we have a lot of garbage here, which we probably want to git ignore, right? So in git ignore, we already ignore assembly files, all files, and now we have to start ignoring dot files and definitely SVG files, right? So that's the stuff we want to ignore for sure. And if I take a look at this entire stuff, as you can see, it's more manageable now. So we have PNG, we don't need that. So all of that garbage is not needed. So I think I can remove this kind of stuff. And it wasn't that much code. Look at that. So that's the entire basically code for dumping the control flow graph. And yeah, so it's actually pretty useful tool. It is in fact pretty useful tool. So let's do a committee. So implement -cf flag for the compilation mode. It dumps the control flow graph of the compiled program as a dot file. So there we go, and I'm gonna push that right into the repo. Pushy, a committee. So, and let's create a pull request. Implement CF flag for the compilation mod. It dumps the control flow. There we go. All right, so I guess we're done with the control flag dumping, and now we can try to go ahead and implement elif keyword, right, to get rid of these trails of end files, because now we have a tool to efficiently debug the control flow stuff, right? If I introduce some sort of error, I can easily, you know, just dump the entire thing and see where I made a mistake. All right, we're gonna do all of that after a small break.